All right, listen up, because in the high-stakes world of AI, a massive upset is brewing. We're talking a classic David versus Goliath story, but instead of slings and stones, the weapons here are algorithms and efficiency. And trust me, the outcome is going to change everything. For years, the answer to this question just seemed obvious. But a whole new generation of AI models is forcing us all to stop and ask, when it comes to raw intelligence, is bigger really always better? The playbook has been pretty simple up until now. If you wanted to build a smarter AI, you just had to make it bigger. Feed it more data, throw more GPUs at it, and scale up the parameters. You can think of those as the little knobs and switches inside an AI's brain. It was basically a brute force marathon. And that whole philosophy led us here, to absolute behemoths like Kimi K2 thinking, a model with a staggering 1 trillion plus of those knobs. This is the heavyweight champion of the world, the undisputed Goliath of AI. But now, meet the challenger. This is MiniMax M2.1, an open-weight model from a Chinese lab, and it's tipping the scales at just 229 billion parameters. That's less than a quarter of the size of the champ. By all accounts, this shouldn't even be a fair fight. And yet, you have to look at this. On the most critical performance benchmarks, this lightweight contender is going toe-to-toe with models that are 3, 4, even 5 times its size. The scores are nearly identical. So what in the world is their secret? Well, the answer is that they're playing a completely different game. Instead of just trying to win at the game of scale, these new challengers are rewriting the rules with a laser focus on radical efficiency. This quote from the developer community just nails it. It's not about brute force anymore. Strong architectural choices means they're building smarter internal structures, things that only activate the parts of the AI brain that are actually needed for a task. And strategic training, that means using super high-quality, curated data instead of just scraping the entire internet. It's all about precision over raw power. And this brings us to the core concept, model efficiency. It's all about wringing every last drop of performance from the fewest parameters possible. Here's the best analogy. It's the difference between a giant, hulking cargo ship engine and a finely tuned Formula One engine. Yeah, they're both powerful, but only one is built for blistering, efficient speed. And nowhere is this efficiency making a bigger impact than in the world of software development. I mean, that's the ultimate test of logical reasoning, right? And this is where these new models are really making their mark. The results are just stunning. On the SWE-bench Multilingual benchmark, which is a grueling test of a model's ability to solve real-world coding problems, MiniMax M2.1 isn't just competing, it's achieving state-of-the-art performance, completely blowing past the competition. But look, we all know benchmarks aren't everything. So the real question is, how does it perform out in the wild? Well, while its test scores are definitely elite and the fact that it's open weight is a huge win for developers, some of the real-world feedback suggests it can act a bit like a brilliant junior software engineer. Absolutely fantastic on specific tasks, but sometimes it lacks that deep context for the really complex senior-level problems. And here's the kicker. This isn't some one-off thing. MiniMax is not alone. Other models from Chinese labs, like Zebu AI's GLM 4.7, are also showing off this incredible efficiency. This proves this is a powerful emerging trend in AI development. So what does this all mean for the future of AI? Why does this matter to you? Well, it fundamentally changes the nature of the entire competition. This whole new approach has 3 huge implications. First, it's going to intensify global competition, with innovative new labs jumping into the ring from all over the world. Second, it shifts the focus of AI development itself, away from just building bigger models to building smarter, more efficient ones. And finally, it puts incredible power into the hands of open-source developers, who can now work with top-tier models that are actually accessible. So the big picture is this. The race to build the best AI is no longer just a simple marathon of who can build the biggest model. It has completely evolved. It's now a dynamic, fast-paced sprint of efficiency. And in this new race, the smartest, not just the strongest, are going to win.